Alright guys, still in dilations. This is slide 10. Looks like we're looking at ratio of line segments. So a ratio is just a division, you guys. It's like a fraction. It's a comparison of two numbers is the definition. So let's see here. Alright, so let's see. So we're going to open up dilations again. Okay, same figures we had earlier on slide 6. Alright, so let's see. Measure and record the lengths of two or more line segments in the original n equals 1. Choose at least two line segments that are not vertical or horizontal. And then scale factors 0.5, 2, and 3 like last time. So what are we doing here? Okay, so we're just looking at the lengths of them. And the ratio. Okay. So let me see. Something that's not horizontal or vertical. Let's see. How about, let's go with something easy. How about LK and HI? That's pretty easy. So LK is this one, HI is this one. Let's do those. All right, so I'm going to do LK, HI. All right, so I need to find the length of LK and HI. All right, so let's see. I'm going to come over here to the angle icon and select distance or length. LK, I'm just going to click on it, is 2.2. HI is that a 3.2? Let me move it so I can see. Oh, it's 2.24 and 3.2. Okay, so 2.24, and this one was 3.2. Okay, so it looks like now I'm going to dilate it. Scale factor is 0.5, which means it's going to shrink. All right, so now it is 1.12. I can't see it. Got to move it. 1.12 and 1.6. Well, it just makes sense. It's half the size. So 1.12 and half the size would be 1.6. All right, so now we're going to get twice the size. All right, so twice 2.24 is 4.47, and twice the size of 3.2 is 6.4. All right, put that in. 4.47, 6.4. All right, now we're going to get 3 times the size. All right, so 2.24 times 3 is 6.71, and 3.2 times 3 is 9.6. So 6.71, 9.6. All right, the ratio of the dilated to the original. All right, so we're going to take 1.12 and divide by 2.24. Let me get my calculator. So 1.12 divided by 2.24 should be 0.5. All right, 1.6 divided by 3.2. 1.6 divided by 3.2 was 0.5. All right, so now for the scale factor of 2, we're going to take 4.47 and divide by 2.24. 0.47 divided by 2.24. Okay, 2. All right, let's see. 6.4 divided by 3.2. 6.4 divided by 3. Whoa, go back. Messed up. 6.4 divided by 3.2 should be 2. All right, scale factor 3, so 6.71 divided by 2.24. 0.71, 2.24. Should be looking at a 3. And last but not least, 9.6 divided by 3.2. And that's a 3. All right, so the ratios just come out to be the same as the scale factor. And that's honestly, you're just multiplying to get the scale factor, so it just makes sense. The opposite is to divide. Here we go. All right, Question 2. In part A, you calculate the ratios. Using GeoGebra, now I'll use the distance formula to calculate more ratios. Choose 2 line segments in the logo that are not horizontal or vertical for a scale factor of 3. Calculate the lengths of the line segments in the image and the pre-image using the distance formula. When you're through, find the ratio. Okay, scale factor of 3 and show your work. Oh my goodness. Okay. So I'm going to do LK again because it's just easier. So L, what's the order pair for L? L is 0. Now they want a scale factor of 3, right? Calculate the line segments, yeah, for a scale factor of 3. So 0, 6. And K was -3, 0. All right, distance formula. Oh, I can't make a big old square root, so you just got to remember that it's there. I guess I could in my equation editor. Yeah, I can in my equation editor. All right, so let's see. So x2, it's going to be -3 minus, and x1 is the 0. And I need that squared right there. Okay. And then there's a plus sign, so I'm going to put a plus. In parentheses again. So y2 minus y1 is going to be 0 minus 6. And I need a squared. Alright, so let's see, that's good. Okay. Alright. Okay, so let's see. -3 minus 0 is a -3 squared. -3 squared is 9. So remember there's a big old square root there. Zero minus 6 is a -6 squared is 36. Alright, so 9 plus 36, that is going to be, let's see, 36, 46, 45. Square root 45. And I need a square root. Do they have a square root? Yeah, 45 square root. It's about 6.7. About 6.7. Okay, so looking for LK, it's about 6.7. Yeah, and that's what we got up here. It's about 6.7. Cool. Alright, so the ratio again would be the same. 6.7 divided by 2.24. 6.7 divided by 2.24, and that's about a 3. So no matter if you use GeoGebra or if you use the distance formula, you're going to get the same 6.7. They got 6.71. And basically it's here 6.71 because that 8 makes that 0 go up to a 1. Alright, done with that one. Alright, question 3. Oh, last one. With respect to the scale factor n, what can you conclude about the ratio of the lengths of the line segments in an image to its corresponding length in the pre-image following the dilation? How is the slope of a line segment in the image affected by this ratio, if at all? Well, we already know the slope doesn't change. Okay, so let's see. When you divide the length of the image with the length of the pre-image, and that's what we did, you find the scale factor. And of course we already know the slope's not going to change, so no, the slope doesn't change by the ratio. We found that in another answer. Alright, so self-evaluate. All right, so it looks like we are done with dilations. So really the take home from this is the scale factor. You multiply to make it either bigger or smaller. You divide to find the scale factor. And we've done this before. I guess we just want to do a little bit more in depth. All right, so there you go.